Hello guys, and welcome to another lesson for this series titled Building Secure, Scalable, Fault-Tolerant and Low Latency APIs with Java and Spring Boot. My name is Ngane Emmanuel, and you are looking at the security section of this course. Today we are going to be looking at injections. If you are new to this series, please I advise you and encourage you to visit previous videos to get a proper understanding so that you can follow with us henceforth. That said, you can leave your comments below and your questions. I will get to them as soon as I can, and also you can subscribe to the channel, click the notification bell, like and share the videos to anyone you find that might need, and this video can be useful too. You can also follow me on my social medias. The link is in the description below, and the link to the repository where all the applications we are building, the practicals and the notes are also found in the description below. That said, let's dive right in. Today we are looking at injection attacks in APIs. So what we have seen so far, we have built a Spring Boot application API, we have introduced API security fundamentals, and now we're exploring injection attacks. So by the end of this lesson, you should be able to understand what injection attacks are, learn why they happen, identify common injection types, understand SQL injection deeply, learn baseline defenses, prepare for practical exploitation demo. So I just want to quickly state this because the slides are very detailed and self-explanatory. In this theoretical lesson videos that I make, we just go through the slides and me reading aloud and highlighting certain aspects that I think will need more touch from me. So if you are already familiar with this, you can just skip to the next video, which will be the practical session. However, I advise you to still continue to watch this one. You might learn a thing or two. So what is an injection attack? An injection attack occurs when untrusted input is interpreted as executable code or command. So instead of being treated as data, user input becomes part of the program logic. And why is this dangerous? Injection attack allow attackers to first bypass authentication, right? It also allows them to read sensitive data, modify or delete data from the database, execute system command, is something you really don't want, and take full control of the system. Before you know it, small bugs become catastrophic impact. So the root cause, right, why of injection attacks are tied usually to input not being validated. Input is concatenated to the commands, right? The system trusts external data, and passing boundaries are unclear. So if you look at our last practical session, at some point when we're designing the repository layer, we concatenated input to the command, to the SQL command, which it's not a good practice because you can use injection attacks to modify that entire query, and something completely different gets executed there. So you can also use injection attacks because the system trusts user inputs. You can use injection attacks to escape a particular directory and have access to different directory within the file system of that of the entire server that you are not supposed to have access to, and you have information which is dangerous and damaging to the organization, which you are not supposed to be having. So injection attacks are really serious business, and these kind of attacks, the system cannot distinguish data from instructions. So common types of injection attacks, we have SQL, which is the most common and the primary attack we are going to be simulating in the, I think, the subsequent videos. SQL first of all starts with simple query language, and this kind of attacks utilizes the SQL commands in order to access your database. So malicious SQL query is injected into database queries. Most common injection type and can leak or destroy database, right? We have command injection. This one is also, I talked about directories, which they use the user input execute operating system commands such as cd, that's change directory, make, and so on. So they can access system files or processes. We also have the lightweight directory access protocol, which also this one is a injection. So this one, okay, this one have operating system commands, yes, and this one lightweight directory access protocol injection, where malicious input manipulates directory queries. So and instead of a particular instead of running a particular code in a particular directory, it changes the directory, and the entire code is run completely somewhere else. So it often impacts authentication systems, right? I think we might simulate something like this. I think so. I don't know, but we'll see. Where we'll just use, we'll try to simulate how a user, an attacker, might send an input and get information from a directory where it's not supposed to get information from that directory, and then we are going to use a common directory resolver to be able to detect whether or not the particular user is within the safe directory where we specify that they should be. So I think we might simulate something like that. And also, if you're resolving lead code questions, I think there's a lead code question that talks about resolving Linux path, and that could be used here to resolve the final path, and using that information to check for authorization. Okay, so yeah, I think it will be a very interesting video to look at. So the next one is deserialization injection, and this one is when malicious objects execute code doing deserialization. Okay, so something like cookies or some objects where you have additional inputs, and the attacker can use extra inputs that contains malicious codes to extend and run code remotely, right? So we are not going to see this one, but it's important for you to understand it and look into it in much detail, right? So the attacker can intercept the data, and do a lot of things with it. Then we have expression injection. Okay, again, it also has to do with remote code execution. And this is where when you use expression language within within your implementation, and then within that expression language you pass in a user controlled variable, and that allows the user to be able to send in malicious code that gets executed within that expression. So it's it's very important that you understand this kind of injections and how to protect yourself against. Okay, so, and this again, I also mentioned that it allows for remote code execution and stuff. So so we're going to look at why SQL injection is so common, right? And that's because database powers almost every system. So SQL injection is the ideal place to start. Yes, and it's also string based, which makes it a bit easy to hack. So we also have the idea that many developers build queries manually, and sometimes their design of those queries can be flawed, and they might not be utilizing the proper security measures, so allowing their applications to be vulnerable. And again, since vulnerabilities are built on past mistakes, we have legacy systems which some systems still implement these vulnerable designs. And so because of their existence, hackers love to exploit the opportunity. So an example of a vulnerability is a conceptual example, and this is, I think, what you see for most tutorials. It's a simple login kind of injection, usually used to log in or gain access to things you're not supposed to gain access to. So you have a simple select query. So you're selecting all from users where username is equal to that. So you're adding here an input, right? An input variable. And this is controlled by the user. Now if the user sends this particular string, this is a string, as the input, then this query says where user is equal to admin, which could be wrong, or now because there's an or, this can be wrong and it will not break the query. 1 is equal to 1, this is true. And so this allows the logic to always be true in queries like this, and grants the attacker access to information that they're not supposed to have access to. So if you don't understand this, I will advise for you to go study SQL, simple query language and database. It's going to make sense. So what happens internally when a code like that executes is, say the database receives a modified query, right? So again, the query has been modified because it doesn't now read as this, it reads as username equals to admin or 1 equal to 1. And then it closes that, and it's always true. Alright, so condition becomes always true again. Filters are bypassed. So the filter, which was supposed to be where username equals to that, which is false, now is bypassed with this all command, this all clause here. So we have data is exposed when the attacker bypasses the filter. So the database executes exactly what is received. So the impact of SQL injections include dumping entire tables by an attacker, modifying records, and you don't really want this when you're in a financial institution, because someone can literally just modify the bank account to have a particular amount of money and you will never know. So and SQL injections don't really send alerts too much, especially when you use well, because again your system doesn't really, it's not raising any red flags, it's not raising any logs, any suspicious activity here. Okay, especially when you don't implement validations. They can delete data, they can escalate privileges, and this is also something you really don't want to happen, because once the privilege is escalated, a common user can become an admin user, and before you know it, your entire system is compromised and is under the control of the attacker, and they can do whatever they wish. They can bypass authentication, as we have seen. So ORMs, object relational mappers, they are frameworks or tools which are used to make database communication easier for developers, and they implement by default security structures to prevent most common security vulnerabilities, such as basic SQL injection. So for ORMs, we have things like Hibernate, JPA, or Spring Data, and we also this is mostly for Java, the Java folks. So they use parameterized query by default, which helps to separate the query structure and the input from the input, right? So this prevents classic injection. So for things like this, you will not be able to do things like this when using ORMs. We're going to see this, we're going to use JPA, and we're going to see how that helps. When we have ORMs, although they help, they still fail, because most ORMs still give the user, the developer, certain flexibility. For For example, they still give you the ability to write native SQL queries. And so most of them, they don't fail because they are bad. They fail because the developer themselves bypass safety by accident when using ORMs combined with older methods. So sometimes, since they don't provide all the possible ways of all the possible queries every developer will need, they still have to design the ORMs in such a way that the developer can use custom queries. And these custom queries now we need to be defined. They need to define the rules of this custom query, the SQL queries themselves. And doing the definition, doing the design of these SQL queries, they can accidentally bypass safety and expose the application. So by using things like string concatenation, dynamic query generation, and also they can misuse stored procedures. Now, these are some common ways how attackers discover injections, right? So they try special characters, unexpected input size to see if you check for input size. They look at the error messages. Again, I spoke about this earlier. I think in the last video, in a couple of videos I've been talking about it. You should not give too much detail with the error message. It should be as generic as it can get, while making sure that it informs the user about an error, but not too specific about the particular error and where it occurs. So the timing changes, they use Boolean logic changes, such so. They also use automation attacks, such as they use automation attack tools such as scanning. They attack tools automatically, so they attack the endpoints, such as scanning the endpoints, right? They use fuse parameters. Is it false or fuse parameters? I don't know how, so I think it's false parameters. I have double Z. And this is very interesting. This is basically a technique that is used to detect those parameters in an API that are not documented, but they exist and the API still considers them. So those parameters are set by default, right? That you would not generally see in the UI. You will not need to input the character, but it's sent by the developer by default. So you can have, like, for example, size or the limit equals to 10 by default, or admin or user equals to admin, or role equals to user, or something like that, depending on the design. So they use this false parameter technique to be able to extract those parameters of an API that are not, exposed to by using the documentation of that API. And when they get them, they can now they can change the parameters and send their own customized parameters, allowing them have extra information or access to different behaviors, or more an extended behavior of the API that is not supposed to happen. And if you have really sensitive information or parameters that grant certain access, it can be catastrophic for you. So also used to detect vulnerabilities, exploit at scale, and speed amplifies damage. So attack tools automatically speed amplifies damage. I didn't write this one well, so sorry about that. But again, if you use automated tools, I think like distributed denial of service, you use automated tools, the speed at which you send the request can, block access to your APIs, and that's how you get like distributed denial of service attack. So the baseline of defense, which we're just going to talk about here, we always use parameterized queries. So we never concatenate user input into queries. Don't ever do this. And always bind parameters safely. Okay, always bind parameters safely. So two input validation. So you want to validate the type of the input, the length of the input, the format of that input, and you have to reject unexpected data which you are not by design is not supposed to count. And I think you will. One of the things we're going to look at is the detail for validation is really good. Is really important. So baseline defense, we have least privilege data access. Again, you want to make sure that your application should always have the limited permissions, right? Just the permissions they need to perform their given actions. You don't want them to have excessive access, right? So if they only need so if you have like a search microservice, a search service, you don't want to give a search service a read and write permission. You don't want to give a search service a write and update permission or delete permission. You want to give it just a read permission so that someone cannot use your search service to be able to dump your entire database. So never use admin credentials again. This gives your application all the permissions, which is not right. So you want to always create a user per application and then create the permission for that user. I think we'll see this. I'll also look into this. Maybe I'll demonstrate this, right? Creating a user in your database and so on. So monitoring. So error handling. So again, do not expose database errors. Very bad. Log database errors, but don't expose them. Log them internally. So return generic message, an error occurs, you cannot process this, blah blah blah. So 5, monitoring. So you always have to monitor. So try to detect unusual query behavior and alert on anomalies. So security versus performance. Here we see that security slows the system, but at least these particular security measures don't slow as much as the network latency does. So we have parameter binding at minimal overhead. Yes. So we have validation costs CPU processing, yes, and also that's additional processing time, and login also increase input output. Again, input output it really increases the time because you need to write to logs, and then you need to write to the logs, then continue whatever you are doing. So that this will slow your system down, but again, it is negligible compared to network latency. The real trade-off, of course, poorly designed security can slow your systems, which is something I've been talking about. You always want to make sure that your security is a trade-off, not too much, but enough. So correct security is usually cheap and breach are extremely expensive. So for our next class, for our next session, which will be a practical session, we are going to build a vulnerable endpoint. We are going to execute a controlled SQL injection. We are going to observe the impact. We are going to fix using parameter binding and validation. We are going to retest that attack, and then we are going to measure the behavior. So key takeaways for this particular lesson. 1. Injection attacks occur when input becomes code. 2. SQL injection is the most common form. 3. ORM helps but do not guarantee safety. 4. Defenses are simple but must be consistent. 5. Practical validation is critical. So that is the end of our lesson for today. If you have enjoyed this lesson, please give it a thumbs up, like, share, and subscribe. Comment your thoughts and your questions in the description below, and whatever you have to say, I'm going to get back to you as soon as I can. Also follow me on my social media in the description below left, both on my LinkedIn, my Instagram, and my GitHub page. Also, the repository for this series is in the description below. Please start the repository and clone it and use it and watch it so that as the changes are made, you can update your own clone of it. That said, thank you for watching and have a nice day. Bye.